Okay, for section 1.6 in this simulation, it says to graph the function, where the function we have at y is equal to -3/4 of x to the third. Okay, and if we plot some points, okay, so to plot points, you click on this box here and say that if x is at 1, well, your y value is going to be at -3/4. Okay, and if we have that x is -1, well, the cube of -1 is -1, then we have times -3/4. So when x is -1, okay, your y is going to be a +3/4. So we plot this point, and you had to plot at least 5 points in the mix. And also we have the origin to be included. And also, let's say that if x is 2, okay, 2 cubed is 8, 8 times -3/4, okay, so this will make -6. And if I do it the other way, in case you have with x at -2, -2 cubed is -8, times -3/4, negative times the negative is a positive, and in this case we had 24/4, which is reducible to +6. Okay, so you have -2, 6. Plotting the point, and then connecting and checking, and the result is correct. Okay, and for what we have in the case of graphing the parabola, which we have represented by the function y is equal to the square of x plus 4 minus 3. And what we can do here is that we can make this x plus 4 as 0. So if I have x at -4, so we have -4 plus 4 is 0, square root of 0 minus 3, so we have a point at -3. I can go ahead and plot this and say if I have x at -3, -3 plus 4 is 1, square root is 1 minus 3 is -2. And if I move, shift one place over, say if I have x at -5, -5 plus 4 is -1 squared is +1 minus 3 becomes -2. And let's say if I move another place over to the right and also to the left, and we'll say that we have for x at -2, -2 plus 4 is 2, 2 squared is 4, minus 3 is 1. And we also have one place to the left. Okay, so if we have x at -6, -6 plus 4 is -2, squared is 4, minus 3 is 1. And then after plotting these 5 points and connecting, we can check, and the result is correct. Okay, and we have for this problem, it says to choose the function that best describes this. Okay, and you can sort of check out. Okay, so it says to choose one. F of x equals 1. Would that be a horizontal line, which we do not have? F of x equals x. This is not it. F of x equals x squared. Nope. F of x equals x cubed. No. Square root of x. No. Absolute value of x. No. 1 over x, closer, but still no. And then for 1 over x squared, okay, if you notice, okay, you cannot divide by 0. Okay, so we have the y-axis to be off limits, and the square of a negative is going to be positive, square of a positive is a positive, and the reciprocals, okay, will still be positive in y. So we have 1 over x squared to be the best choice. Now we have a horizontal line, so you have y is equal to 1. In this case, f of x equals 1. And then we have, for graphing, okay, we have 0, 0, 1, 1, -1, 1. And you got 2, 4, -2, 4. And the y values turn out to be the squares of the x values. So we have f of x is equal to x squared. And then we have, looking at the trend here we have in part D, we got 0, 0, 1, 1. And we got 4, 2. Okay, so past the origin. Now the y value is going to be smaller than the x value, and this will likely be the square root of x, and we have upon checking, and that result is correct. Okay, for what we have in this problem, we have the graph of y is equal to f of x is shown, and it says to draw the graph of y is equal to f of -x. Okay, so for y equals f of -x, Okay, we're looking at reflecting about the y-axis. Okay, so the y values will change, but you're going to take the additive inverse of the x values. See, we have for f of x, we have like -2, -4. And if I change the x value but keep the y, then we'll have 2, -4. Plot that point, and we can say for the endpoint that we have in the upper left-hand region, okay, we have -6, 4. And guess what? Reflecting about the y-axis, I'm going to have the change up where we have x at 6 and y to be fixed at 4. And then just connecting the dots. So this is what we have here for y equals f of -x. And for y is equal to the opposite sign of g of x. Okay, so in this particular case, we're going to have reflection about the x-axis. So in this case, right, we have we're going to have a change up in the y value for while we have the same x values. Okay, so we still have the origin, and where the function g of x, okay, is going to be consisting of -3, -3. Okay, what we're going to have in the negative of g of x, we're going to have -3, still fixed for x, and the y coordinate is going to be +3. So we plot this, and then we have say -7, 1 for g of x. And for what we will have in the case of the negative of g of x, okay, so we have -7 and -1. And plotting. And then we have getting out of this and connecting the dots. Then we have upon checking, and the result is correct. Okay, it says here below is the graph of y is equal to x, and it says to make the graph of y equals the absolute value of x plus 5 plus 3. Okay, so think of like the absolute value of x plus 5. Okay, so think of like x plus 5 is a 0, and so I will shift over to x is equal to -5 for what we have so far, and then we have a plus 3. Now any addition on the outside, I'm going to shift upward 3 units. And so we have the vertex will go from the origin to what we have with -5 and 3, and checking the result, and it is correct. And we have for this function, it says that the function f is defined by f of x is equal to the square root of x, which we have in blue, and g of x we have in red, and it says to write down the expression for g of x. So if you notice for g of x, now we're still going to have a square root function. And if you notice, you have going from the origin to x equals -4. So think of like taking x plus 4 and setting to 0, or in this case, like x equals -4. We can say this will come from the binomial x plus 4. So your horizontal shift is going to be -4. And notice we have g is above f and sideways, so we have 2 units. So while the y coordinate of f is at 0, that of g is going to be at 2. So we have the square root of x plus 4. And we have followed by the addition of 2 and checking, and the result is correct.